solve the problems in polar plot. So here the open loop transfer function of a unity feedback system is given as g of s equal to 1 divided by s into 1 plus s into 1 plus 2s. For this transfer function, you need to sketch the polar plot and determine the gain margin and phase margin. The first step in polar plot is that you have to find the frequency response from the given transfer function. So the frequency response g of j omega has to be found from the transfer function g of s. So g of j omega is simply wherever we have s, we have to replace it by j omega. So we know that 1 by s is to be j omega. So let me change the color. So 1 by j omega into 1 plus here we have s, so that I am replacing by j omega. Here we have 1 plus 2s, so 1 plus j times 2 omega. So this is what the step number 1. After that we have to find out the magnitude response and phase response. So that is what the step number 2. So we have to find the magnitude response. So we know that the magnitude response will be magnitude response. Before we are going to the magnitude response, first we should aware about how do you find the magnitude of a complex number a plus ib. If it is of this format, then the magnitude will be square root of a square plus b square, right? So you have to remember, then you can proceed, right? So here, if you want to find the magnitude of g of j omega, what you have to do is that just you have to use this formula 1 by j omega. Here there is no real part, so square root of real part is 0, so 0 square, imaginary part is omega, so I can put omega square. Similarly here, real part is 1, so 1 square plus imaginary part is omega, so I can put omega square. Similarly, here square root of 1 is there, so we have to put 1 square, and 2 omega is there, that is imaginary part, so I can put 2 omega the 1 square. So now we have to simplify it. So by simplifying it, we'll be getting the answer as magnitude of g of j omega equal to 1 divided by square root of 0 square plus omega square is square root of omega square, and this one 1 square plus omega square is 1 plus omega square, and this one square root of 1 plus 2 omega the whole square is 4 omega square. So this is what the value, right? Now this is the magnitude, right? Now we have to find out the phase response, that is the step number 3. So for finding the phase response, you have to consider the equation. Which equation? G of j omega equation, you have to consider it. Before that, you must aware about how to find the angle of a complex number, or how to find the phase of a complex number a plus ib. That is tan inverse of imaginary part ip divided by real part rp. Here the imaginary part is b and the real part is a. So tan inverse of b by a is the formula for finding phase of any complex number. So now we know that here we have g of j omega equal to 1 divided by j omega 1 plus j omega 1 plus j 2 omega, right? So now this response we have to consider a g of j omega, that is we calculated previously. So for finding the angle, we know this is a formula. So now, so the angle g of j omega, the phase will be. So now we have to look at here j omega is there. So tan inverse of what is imaginary part is omega. What is real part is not there. So 0, right? So now what is this 1 plus j omega? We are going to find this phase. That is tan inverse of what is this j omega, so we can replace it by omega because that is what the imaginary part, and here we have 1. And what about here tan inverse of what is the imaginary part, that is s 2 omega, and what is real part, that is 1. So tan, so now all the values are available in the denominator, so I can put minus sign in front of everything. So now this is what. Now, what is the simplified answer? What is the minus tan inverse omega by 0? That is anything divided by infinity. That is minus tan inverse of infinity. And here, minus tan inverse of omega by 1, I can put it as omega. And minus tan inverse of 2 omega 1, no, I can put as 2 omega. And which place tan inverse equal to infinity? We know that that is 90 degree. So minus 90 degree minus tan inverse of omega and minus tan inverse of 2 omega. That is what the phase we are in interstellar. So now we found the expression for both phase as well as the magnitude. Now after that, both phase response as well as the magnitude response. Both the thing we have found it. So now our job is to use the various frequencies omega for finding both magnitude response as well as the phase response. So that is what we are going to do in the next step. So that one we know. How do we find the after finding both magnitude response and phase response? We have to apply various frequencies and we'll try to find out the values. Now I have assumed omega ranges from 0.35 to 1 and I have found the corresponding magnitude and phase. You know that how to find out those values using our calculator. Just type the equation using the equation method and try to replace the various values of omega, right? So that part I'm not going to do anyway, right? So this is what the values. Now we'll go for a body plot, sorry, polar plot, and we'll plot everything, right? We'll go for a plotting section. So these are all the magnitude and phase values for the various ranges of frequency. Now this is our polar chart. You know how to handle this polar chart. So this is our center point. After that, what we'll do, we will put a straight line, horizontal line from the center point. So that is the rightmost value is 0 degree, and here the value as you are moving clockwise, that is positive angle. As you are moving anti-clockwise, the angle is negative. Simply you can remember the big letters 10, 20, 30, 40. Those are all positive angles. And the small letter, here we have my 10, 20. So those are all minus 10, minus 20, minus 30. So remember. So if it is 0 degree and this is minus 90 degree and this is minus 180 degree and this is minus 270 and this is minus 360 at 0 degree. So those things you must be aware about it. So in our problems, always we will move on clockwise direction because mostly the angle will be in negative, right? So now we'll first find out what is the value, right? So before we are going to the value, just familiar with the polar chart. See here the polar chart, many circles there, right? So here the circle. Each circle corresponds to the particular magnitude. So now we have a circle now. Each circle corresponds to the particular magnitude. Let me consider each circle. The one circle is each circle, right? So let me consider one circle equal to 0.1 magnitude. If that is the case, tell me guys, how many magnitude or how many circle can form a unit circle? That means how many circle can form a unit radius circle, right? That means if you want to form a circle with a radius 1, how many circle we are in need of with a magnitude of zero point 0.1? So obviously if there is 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 6, 0.7 and 1. So 10 circles we are in. If it is 1 and this is also 1. And here if you want to find the magnitude 2, so that is 2. From 1 we have to travel 10 point. Here also 10. So 2. Remember guys, don't put minus 1 minus 2 because these are all the circles. Circles have the radius of an have been a positive, right? So here 2 and this is 3 and this is 4 and this is 5. So all along the means right side also the value could be 3, 4 and 5. I hope you know, right? So now our job is to plot the point. So first point is 2.2 minus 1.4 minus 44, right? So now I am going to plot it. So this is 2. So this 2 means this is 2.2. 2 lendo 2 points. So 2.2. So now I am moving down. So now I am moving down 2.2. So minus 44. Here the value is minus 90. So where the value minus 140. Here the value is minus 140. So 140, 141, 142, 143, 144. So now we will try to find out, I mean, try to figure out the values. Now we have to find out the intersection point. So this is our intersection point. So this is the first point where my omega equal to 0.35. That's it. Similarly, we have to find out the remaining points. So here the value is 1.8 minus 150. So 1.8 is where, here the 1.8 is where, 1.8 is 2. So before 2, we need to move 2 points. To 1.8 minus 150. So 2, So this is 1.8. So 1.8 minus 150 is this point. This is because this is minus 140. So minus 150 is this point. So 150 is 1.8. So this is the value where this point corresponds to, change the color. This point corresponds to omega equal to 0.4. So similarly, we have to go for next point. What is this 1.2 minus 112, right? So where the value 1.2 minus 1, right? So 1.2 is 1. So before 1, you have to travel 1.2. 1.2. So 1.2, what is the angle? 1.2, the angle is minus 112. So minus 112 means where could be? Sorry, minus 162. I hope minus 162, not 112. So here the value is minus 162. Don't make a confusion on it. The angle is minus 162. So 1.2 minus 162, where the value could be. So here 1.2, here minus 160 and minus 162 is around here. So this is the next one. And what about the next one? So here you have to write down the omega equal to 0.5. So what is the next one? Zero point 0.6, that is zero point 0.9 minus 179. So where the value 0.9? So before this one, so the value is zero point 0.9. So value is minus 171. So here 170 is this one. So this is the place where the value could be marked, right? So here the value of omega equal to 0 0.6. Now go for the next one, 0 0.7. So 0 0.7 minus 180. So where is the value? 0 0.7. So here the value could be. See, when you're finding the values in the calculator, there should be some deviation in your method, right? So now I have used these standard values which I have calculated. Don't bother about that, right? So here 0.7. So here this is 0, 0 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, and 180. So this is what the value. Next value is what? Next value is zero point 0.3 and minus 188. So at the value is zero point 0.3, here the value could be zero point 0.3. So 0, 0.1, 0.2, 0.3 minus 188. So this is minus 190. So this 200. So before this one. So minus 198. So here as you are moving towards the circle very closer, the point could be marked very carefully. So the 0.3 would be like here. So you can mark it in 200. There is no issue at all because both is similar, right? So this is the value omega equal to 1, right? So now what you have to do is that after finding all these points, just you have to connect all the values. That's it. So now I have to connect all the values. So change the bright color, right? So now this is the value. So here these are the points. So now we are interconnecting all the values, right? So this is our polar plot. That's it. Now, after this, we have to find out the two important things. What is that? One is called gain margin, another one is called phase margin. So, what is gain margin and what is phase margin? Right? So, first you will find out the phase margin and we will go for the gain margin later. Right? So, now phase margin is the polar plot and unit circle. You know where the unit circle is, right? So, where the unit circle is? The unit circle is the circle drawn with the radius 1, right? So this is what the unit circle. Now you guys can see that both the unit circle, see this is a unit circle, right? The value could be 1, right? So both the unit circle and this one polar plot is intersecting at one point, right? So this is the point. Can I trace those points at the outwards like this? Can I trace that point outwards like this is the point? So now we have to find out this is the point where these two circles are meeting, right? So now we have to mark those points. That is nothing but pi gc, right? That pi gc you have to add it with the 180 degree. So if you want to find the phase margin gamma, so you have to add 180 degree plus pi gc. So 180 degree plus pi gc is what? Here the value could be 170 and this is between 160. So can I assume 165? See, this is my own assumption. Don't take this final answer. 160 and this is 165. So the answer could be 50 degrees. So the phase margin is 50. That's it. Now, if you want to find the gain margin, what you have to do is that this polar plot and your real axis. Real axis means this magnitude axis. It's intersecting at one point. Where it's intersecting? It is intersecting at minus 180 degree, right? So now this polar plot and the real axis intersecting one point. What is the point? That point is 0.7 here. Here the point is zero point 0.7, right? So here the value is zero point 0.7. So from here, so this is where your polar plot is intersecting with minus 180 degree. The value is zero point 0.7, right? So now the value is zero point 0.7. So now what I have to do, if you want to find gain margin GM, you have to find out 1 divided by what is the value G of J omega at that particular frequency, that is omega gain, gain transfer frequency. That is 1 divided by zero point 0.7. You have to find it and you will be fine. Came to know what is the value. So 1 divided by zero point 0.7 is 4, right? So 1 divided by zero point 0.7 is 1.42. So now this is the gain margin. If you want to find out the values in dB, you have to use 20 log of 1.42 if you want to find out the gain margin in dB, right? So 20 log of 1.42 is 20 log of 1.42 is 3.0. So that is the answer, 3.04 dB, right? So this is how we have to proceed the problem. Thank you.